So in the previous video we saw that the Fourier series f of x equals to some constant plus the summation of all the terms from n equals 1 to infinity of a sub n cosine of nx plus b sub n sine of nx. We see that the constant term that we called also a sub naught divided by 2, this is equal to 1 over 2 pi times the defined integral from minus pi to pi of f x dx. Alright, now let's continue with the other ones. So first let's find the a sub n terms. Let's multiply everything by cosine x. So we will have fx cosine, let's multiply everything by cosine of nx. So fx times cosine of nx is equal to c sub naught cosine of nx plus, and we will have here, remember that we have expand here, is the same as a sub 1 cosine of x plus a sub 2 cosine of 2x all the way to a sub n cosine of nx. So here I will have a sub 1 cosine x cosine nx. You could put n or you could put k, so I'm talking about the k number, whatever. I think that the video that I did on Spanish, I put it a cosine of kx and not using this same n. Well, anyway, so plus a sub 2 cosine of 2x times cosine of nx all the way to a sub n cosine of nx cosine of nx. And here on the bottom, let me put plus b sub 1 sine of x cosine of nx plus b sub 2 cosine of sine of 2x cosine of nx all the way to b sub n cosine of nx cosine of nx. Alright, so now let me do the defined integral from minus pi to pi dx. So the defined integral from minus pi to pi dx, and here the defined integral from minus pi to pi dx. Just give me a minute to put all these terms. Alright, now, so on this side we have, remember that the constant we can take it out and we will just have to define integral from minus pi to pi of cosine of nx, that is 0. So this term goes to 0. Then here we have the constant, we can put it out and we just have the defined integral from minus pi to pi of cosine x cosine nx. The same here, the defined integral from minus pi to pi of cosine of 2x cosine of nx. So it's just a constant times this. Whatever it be, all these terms goes to 0, except this last term, because here I have a sub n cosine nx times cosine of nx. So this term actually is the defined integral from minus pi to pi, and let me put out the constant, so a sub n times the defined integral from minus pi to pi of cosine square of n or cosine nx square, whatever, and dx. So this is not this term. This term is this term. And so in this case, we have the defined integral from minus pi to pi of fx cosine nx is equal to a sub n times the defined integral from minus pi to pi of this is, you know, pi, so I here just have a sub n times pi. And let's continue with these terms. Here I just have sine x cosine sine of nx, sine x cosine nx, sine x cosine sine of 2x cosine of nx, and here all the ways including sine nx cosine nx. This would be this term. So all these ones will go to 0, 0, 0. So I just have this equation, and this leaves me with a sub n being equals to 1 over pi times the defined integral from minus pi to pi of f of x cosine of nx. So it's similar in a sense to C naught, because remember that a sub 0, remember that a sub 0 is 1 over pi times the defined integral from minus pi to pi of f of x dx. Here I forgot to put the dx. So the only difference is that a sub n would have the defined integral of f of x cosine nx instead of just f of x, and here a sub naught is a sub naught divided by 2 is the constant. So we have 1 over 2 pi. Here we just have 1 over pi, but not get confused because here we have f of x cosine nx, and here we just have f of x. So this was for the cosine terms, or the terms that contain cosine, and this was the coefficients of a sub n.